Section 5.2, Sum and Difference Formulas. Part 1 of the notes. In this section, we're going to focus on the sum and difference formulas that you see here on your screen. So we might be interested in finding something like cosine of 15 degrees, which if we look at our unit circle, 15 degrees isn't a reference angle, but we could rewrite 15 using two reference angles, whether we're adding them or subtracting them. So that's kind of how we're going to use these formulas here. So take a minute and copy these down onto your notes. Example 1. Use the sum and difference formulas to find the exact value for cosine of 15. So one really important thing I want to tell you here is do not pick up your calculator for this entire concept. Okay? I know we can just plug this in our calculator and we can get the right answer for most of our calculators, but I'm going to be looking for your work on the homework and the test, so just putting it in the calculator isn't going to help you. So first of all, we notice that 15 is not on our unit circle. If it was, we could just look at that reference angle and say what the x coordinate of the point was. So what I'm going to do is I'm going to think about how I could rewrite 15 using reference angles on my unit circle. So I can rewrite 15 as 60 minus 45. So I'm going to use my difference formula for cosine. And my u, I'm going to plug in 60, and for v, I'm going to plug in 45. So we have cosine of 60 minus 45 equals cosine of 60 times cosine of 45 plus sine of 60 times sine of 45. Now at this point, we can think back to our unit circle. We know what cosine of 60 is. We know what cosine of 45 is, so we can just plug in those values. Just a quick reminder in case you forgot, cosine of 60, we're thinking about our unit circle, we think about where 60 is, and cosine is always my x value. Sine is always the y value. And now all we need to do is simplify this algebraic expression. So we're going to start with the first two, 1/2 times square root 2 over 2. And we get square root 2 over 4, multiplying our numerators and denominators. And then we get plus square root 6 over 4. We're going to rewrite this as one fraction, and we get a final answer of square root 2 plus square root 6 all over 4. Example 2, we're going to use our sum and difference formulas to find cosine of 75. So again, 75 is not a reference angle on our unit circle. So we're going to find two reference angles that we can rewrite to equal 75. So for this problem, we're going to rewrite 75 as 45 plus 30. So I'm going to use my sum formula for cosine. And my u is going to be 45, and my v is going to be 30. Now, since we're adding 45 and 30, I could have switched them. I could have had 30 plus 45. It doesn't matter. It matters, though, if we have a subtraction problem going on. So let's plug in 45 and 30 for all of our u's and v's. And now we can think back to our unit circle, figure out what cosine of 45 is, cosine of 30, sine of 45, and sine of 30. Again, we're just going to simplify this now by combining fractions and then rewriting it as one fraction. Example 3, find sine of 165. So again, I'm going to look at how I can rewrite 165 using reference angles. And there's probably a few ways. but I'm going to use 135 plus 30. So we have our sine sum formula. And we're going to use 135 for u and 30 for v. Again, since we're adding them, it doesn't matter if you do 30 for u and 135 for v. So plug in our values for u and v. And now think back to your unit circle. Be careful this time because 135 is not in the first quadrant, so we might have some negatives going on. And then again, we're going to multiply our fractions together and condense them into one fraction for our final answer. Example 4, we have tangent of 105. So this time I'm going to rewrite 105 as 135 minus 30. So we're going to use our tangent difference formula. This time it does matter which one we plug in for u and v, because if we switched them, 30 minus 135 would not be equal to 105. So be careful here that you plug in 135 for u and 30 for v. All right, thinking back to our unit circle, tangent is always y divided by x. So be really careful. You may have to do some work out to the side to figure out what tangent of 135 is and what tangent of 30 is. Now notice for tangent of 30, I use square root 3 over 3. If we were to divide our y over x here, we would have 1 over square root 3, but I want to rationalize that, so I rewrote it as square root 3 over 3. Now to simplify the bottom, I've got negative 1 times square root 3 over 3. I'm just going to rewrite this. Now, this is our final answer. This is good enough. It's not in a very good form, but it's going to be good enough for right now. If you are someone who's moving on to calculus, though, if calculus is the next step in your math career, if you're going on to further high-level math, then this is not an acceptable answer. And I'm going to walk you through how to rationalize this, and you would be expected to know this next year. Okay, so to rationalize this, I'm going to start by combining my terms on the top and the bottom. So I'm going to rewrite 1 as 3 over 3. Condensing the top to one fraction and condensing the bottom to one fraction. I'm going to keep flip change. So I'm keeping the numerator the same. I flipped the denominator and I changed to multiply. I can cancel a 3 out of the top and the bottom. And now I'm going to rationalize. I'm going to multiply the top and the bottom by the conjugate of the denominator so that I no longer have a square root in my denominator. So I'm foiling on the top and foiling on the bottom. And then I have a common factor of 6 that I can cancel out of all of those terms. Again, if you are moving on to calculus next year, this is the answer I would expect from you. If calculus is not going to be something that you're moving on to, then I'm fine with the previous answer that I said.